All right, so we're going to continue working with proportional relationships, tables, and graphs. We're really focusing on table or on graphs today, so we're going to use some web stuff, which is why we're using the McGraw-Hill curriculum, not me drawing pictures because I can't draw it nearly this well. So we're going to look at how graphs of proportional and non-proportional linear relationships are alike and how they are different. So we've got this whole word problem we're going to go through, and then we'll get to play with some graphing tools. All right, so several of the students in Mr. Bowman's math class joined in an online discussion. Why did this not reset? Cool. Joined an online discussion. Each student posted 4 comments. The number of replies to each of their comments is shown in the tables. Drag the correct ratio in the simplest form to the tables to find the ratio of the number of replies to the number of comments for each student. So we're going to start here with Albert, and in order to figure this out, I'm going to use my learning tools. It's going to give me a blank canvas to do some math on. All right, let's make it a little bit longer because maybe, there we go. All right, so let's look at Albert. Remember up here it says we want to make the ratio of the number of replies to the number of comments. So that means that the replies is my first number and my comments is my second number, or my replies is my numerator and my comments is my denominator. So if I write the ratio of replies, so we have 2 replies to 1 comment. My bottom number is already 1. That is already a unit rate. I don't need to do anything to it. So I'm going to go ahead and drag this 2 over 1 to that spot. So let's look at the next one. Remember, we're doing replies to comments. So your replies is 4 comments. And your comments is 2. Whenever I have something like this, I want to try and get the bottom number to 1. Well, I know 2 and 4 are both even numbers, so I'm going to go ahead and divide by 2. I can always divide even numbers by 2. I also can try and divide by whatever the bottom number is. So 4 divided by 2 is 2. And whatever I do to the bottom, I do to the top, and 2 divided by 2 is 1. So let's go ahead and drag 2 over 1 over there. So then let's look at 6 over 3, or 6 to 3. Well, they're not even numbers, so I can't just do 2. But I can divide 3 by 3 to get 1. And I know 3 is a multiple of 6, so let's go ahead and do that. So 6 divided by 3 is 2. 3 divided by 3 is 1. So I can go ahead and drag that there. And then our last one of 8 replies to 4 comments. So these are both even numbers, so let's go ahead and divide by 2 since they're even. My computer's crying right now. 8 divided by 2 is 4. 4. 4 divided by 2 is 2. But they're still even numbers. Let's divide by 2 again. 4 divided by 2 is 2. 2 divided by 2 is 1. So we have 2 over 1. Let's check our answer. We got them all right. All right, let's go to the next one. If my computer will cooperate. There we go. All right, so now we have Connie. So we're going to go ahead and clear all our math from our first one. So Connie, remember, we're doing replies, number of replies, all right, to number of comments. So that's 1 to 1. I don't need to do anything else. My denominator is already 1, so I'm going to drag that over. So then my second one is 5 to 2. Well, I could divide by 2, but that gives me a decimal. And none of my options have a decimal in the top. So 5 and 2 don't have any common factors, so I'm going to leave it as is. Drag that 5 over 2 to that ratio. Next, we have 9 to 3. 9 replies to 3 comments. Well, I know that 3 is a multiple of 9, so I'm going to go ahead and divide by 3 because that's how I turn the denominator into 1. So 9 divided by 3 is 3, and 3 divided by 3 is 1. So we're going to drag that answer in. And then our last one is 13 replies to 4 comments. Well, 13 isn't an even number, so I can't divide by 2. And I know that 4 times 3 is 12, so there's nothing that I can put that would be 4 times anything to get 13. So that's going to stay the same. So I'm going to drag that in. Let's check the answer. There we go. Let's go look at how many Bianca's ratios. So I'm going to go ahead and clear all my work. We're going to try again. So Bianca, she had 1 reply. My pen will work. Oh, I got to turn the pen on. It helps. 1 reply to 1 comment. Nothing I need to do. Let's drag that over. And then I have 4 replies to 2 comments. Hey, look, they're both even numbers. Let's divide the top and the bottom by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. There's our fraction. There's our ratio. Let's go ahead and move that. Next, we have, oops, not 3 on top, 7 replies to 3 comments. Well, 3 times 2 is 6. So there's not going to be anything that I can put there. 7/3 is a choice we have. Remember, we're looking for the most simplified. 7/3 or 7 to 3. And then 10 to 4. Well, I know I can't divide by 4 because 4 times 2 is 8. And there's not enough, 4 doesn't go into 10. So again, remember they're both even numbers. So let's go ahead and divide by 2 and see what we get. So 10 divided by 2 is 5. 4 divided by 2 is 2. We already had this one earlier. I can't make that any simpler. So we're going to go ahead and put 5, 2. We got those correct. All right, and now for David. All right. So let's clear our work pad. Clear all, clear. All right, so David had 3 replies to 1 comment. My denominator is already 1. I can't go any simpler. So we're going to go ahead and move 3 to 1 in. Then we have 6 to 2. All right, well, those are both even, and the denominator is 2. So let's divide by 2. Divided by 2, divided by 2. 6 divided by 2 equals 3. 2 divided by 2 is 1. Hey, look, 3 over 1. All right, then we're going to do 9 over 3. Well, I know 9 and 3 share a multiple, and to get 3 to 1, I'm going to divide by 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. Look, we're going to put 3 to 1 there again. And then we have 12 to 4. Let's try. So I can divide by my denominator, which is 4, to get that 4 to a 1. So 4 divided by 4, we know is 1. 12 divided by 4 is 3. So we're going to put our 3 to 1 there. Cool. We got all of those right. Let's go look at the next page. So it says drag each student's name into the appropriate box and bin to determine if the relationship as it where did it go? Oh no. Nope. I want to go previous resource. Hold on. It just like totally disappeared on me. Next resource. There we go. We were on slide 3. Did it reset? It did reset. Awesome. So drag each student's name to the appropriate bin in the relationship between the number of replies and the number of comments for each student is proportional or non-proportional. So if we look at Albert, all of his ratios are the same. Because they are all the same, that means it is proportional. If we look at Connie, her ratios are different, meaning she is non-proportional. If the ratios don't equal the same thing, it is non-proportional. So Bianca, none of her ratios are equal, would be non-proportional. David would be proportional because his are all the same. They are all equal. So we said Bianca is non-proportional and David is proportional. All right. So we got that. So the next page, this is where it gets fun. All right, so we're going to use this sketch. So it says how to use it. The graph points on the coordinate plane. Show the point icon. Then select the location on the graph to place the point. Press the Show Tables button to show the data for each student. Use the sketch to graph the points. Comment number of replies, and for each student. After you've graphed the points, press the Show Graph button to show the lines for each student. All right, so we're going to start with show tables. Let's start with David, so we don't have to scroll a whole lot. Oh, before we do that, let's reset this page. I forgot to reset all of these. It's okay. All right. So let's do show tables. So we're going to work with David. So let's go ahead and graph this. So we're going to look to graph 3 to 1. So let's look. So the replies is my up and down, my y-axis, and the comments is the bottom. So he had 1 comment for 3 replies. So we're going to click our point. We're going to go to 1 comment over. We're going to go up 1, 2, 3, put the point there. And then David's next was 2 comments and 6 replies. So we're going to hit our point, 1, 2, and then go up 6. 1, 2, 3, 4, 5, 6. And then David had 3 comments and 9 replies. So 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Up, I forgot to put my dot in. And then the last one is 4 comments and 12. So press your point, go 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are all of David's points. Bianca, so let's draw that line. Let's look at this. So David's graph. If I draw David's graph, what I notice here, remember this is important. In order to be a proportional relationship, the line must go through the origin. See that point there? That is where it going through the origin. If I were to do Bianca's, let's see, so she had 1 reply and 1 comment. She had 2 comments and 4 replies, so 1, 2, 1, 2, 3, 4. She had 3 comments and 7 replies. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And she had 4 comments and 10 replies. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so if we just did Bianca, right? Yep. If we show Bianca's graph, If you look, it runs almost exactly the same to David's, but it doesn't go through that origin point. In order to be a proportional relationship, it must go through that origin point. So if we look at Albert's graph, we see that it goes through that origin. If we look at Connie's, it doesn't go through that 0, 0 origin. It has to go through 0, 0 to show, there we go, that it is proportional. So how are they alike and how are they different? Well, they're alike because they make straight lines, but they're different in that a proportional has to go through the origin. And that's what this next resource talks about. I think it's the right one. Uh-oh, nope, this one. This is the one I want. It tried to skip something. All right, so proportional relationships go through the origin. You can look at this and see that it goes through that 0, 0. It is proportional. If it does not go through 0, 0, it is not proportional. So a graph shows a proportional relationship if it goes through the origin. A graph shows a non-proportional relationship if it is not a straight line. Go ahead and work on the examples. They're going to walk you through how to identify this. This is an assignment you have, so make sure you get that completed. It's some data, and then you have lesson 1.4 spiral review for homework from today. Thank you so much.